here at the HydroGEN or hydrogeneration.org landing page. And just to remind you, what makes our platform unique are on-demand watershed forecasts that are more than just stream flow and that are seasonal outlooks. And what we do is we train machine learning emulator models on advanced physics-based simulations. And of course, this is only possible because of the great team that we have. Anyway, I'm going to dive right into the demo. So here's our landing page. And first we log in. I'm going to log in with my Princeton credentials. We're using Keycloak as our login, as our authentication platform. And I'm going to walk you through a couple things here. First, we've got existing domains that I've created already, so the user gets a dashboard, the user can share domains, the user can save domains, they can go back and revisit domains. But we're going to create a brand new domain. So we're going to call this our Expo test domain, and then we're going to define our watershed area. And so we have two different options. First, we have our CONUS1 domain, which is being shown here. And our CONUS1 domain is our first generation National Hydrologic Platform. And I'm showing HUC10s here. We can also show CONUS2 just to let you know that we are ready for the next generation. So we've got another hydrologic model that we're also training emulator models on and simulating, and that is going to be the second CONUS platform that we develop. So we are going to zoom in. We're going to pick a test watershed outside of Denver, Colorado on the Front Range. So we select. This is actually going to show us our selection here. This is the Lower Clear Creek watershed, and we're going to hit Create Domain. And so now what's happened is you can see, shown here, we're collecting data, we're actually pulling, we're not just like clicking on a button, we're actually doing calculations at this point. And all of this is being run as microservices in a Kubernetes architecture. So we now have the ability to explore results, which I'll talk about. We have the ability to generate scenarios, which I'll do in a second. And we can also update our domain if we want to, make it public, share it, etc. Now, before I do, I want to highlight that there's a lot of help that's built in, particularly in like creating a domain or talking about our existing domains, and all of this help is sort of throughout the entire platform. Now, what I'm going to do before I explore results is I'm going to generate a scenario, because that takes a few seconds to do. So I'll do that while that'll be running in the background while we're talking about the results. So I'm going to, from the scenarios, and again, we can pick different kinds of scenarios. These are weather scenarios for a 3-month period, starting today and then moving forward. So this is a seasonal outlook. And I'm going to pick an average scenario, which is pulling just randomly average years from the past. It's going to pull 4 different years. So now it's building our forecast. So we can go back to our dashboard, and we see that we're actually got a status bar, we're generating the scenario, we're pulling data, etc. And while that's happening, I'm going to just dive into the beginnings of our Explorer results dashboard. So here we have our site location. We have our heat map of current conditions. This is water table depth. We can also look at soil moisture. And we can also dive into all of the available point data. So we have the Hydro Data platform, which is part of the HydroGeneration or HydroGen platform. And here we can walk through and look at stream flow, or we also have the capability to groundwater. We can look at observations within our domain, as shown here. And we could even jump into an observation explorer. So this allows us to, for example, we can look at Clear Creek at Golden, and we can scan, manipulate, we can slice this. This is the available USGS gauging record for this particular site. And this in and of itself is a pretty great kind of exploratory tool, coupled with our current conditions, which were downloaded, simulated and downloaded from the platform. And then, of course, we can download our results if we want to. So we can pull all these results down and download them if the user wants to. And again, we have context-sensitive help that tells us, what we're looking at and what's going on. So let's check back in on our dashboard and see if our scenario is finished. So here's our Expo test, and we can see that it's still generating the scenario, it's still doing the simulation. This is actually multiple parts. This is pulling down data and also running our machine learning emulator model. So we have a machine learning emulator model that's trained on Parflow, that's being run on demand in an ensemble fashion over a 3-month period using the scenario that we just chose. And so while that's running, we also have a help system. So we have a support system, and then we have a help system. And this help, we really think of it as a education or user engagement component. And a lot of our users are very knowledgeable in hydrology, very knowledgeable in a lot of aspects of hydrology, but they're not necessarily experts in machine learning. And so we have a glossary, we sort of have an explainer here so that we can describe what different components are. And then we have explainers for our users that help them walk through things like machine learning, physically based models, and the training process, so that we have a really kind of rich help and user engagement component. So I'm going to jump back now to our dashboard, and we see that now our Expo test, this says scenario ready, which means that we can go in and explore our results. So now we have not only current conditions, but we can see our weather scenarios. So remember, we did an average scenario. So this is our ensemble of our different forcing variables. These are daily forcing for 3 months. So precipitation, min-max temperature, average temperature, and solar radiation are what are needed or what are used in this particular scenario. And so you can see that we can manipulate them, but then the user has, they understand what is driving their simulation. And then we jump to the watershed forecast. And so this is the results of the machine learning emulator, right? So we ran in real time, we ran a machine learning emulator simulation. And you can see here we've got soil moisture and water table depth. These are our starting initial conditions. And then we've got our time series. And this is our change in soil moisture out to 90 days. And we could also do change in water table depth. So you can see that our mean water table depth is decreasing, right, as we move into a hot summer. And our change in soil moisture depends mostly on the precipitation, right? And this is average over the domain, time series forward. We also have heat maps of our simulations as well. We have heat maps of our simulations as well, and this demonstrates that, so this is just the change between one of our scenarios, one of our 4 scenarios, and the starting point. But what this demonstrates is that we have a full 3D, so full 3D simulation forward in time, so a 4D aspect of our results, and we can slice and dice and provide these widgets any way we want. So these widgets are flexible, they're designed in a very componentized manner that we can change them out or customize them, and they're just an example of what the simulation looks like. So now, after this quick demo, taking us back, so we have HydroGEN project, we have on-demand watershed forecasts, more than just stream flow, and these seasonal outlooks. And this is a really unique capability that I've just demonstrated, but we're end-to-end and we're national. And thank you very much for listening in, and please reach out if you have any questions or you want to be part of the beta testers. Thanks a lot. Bye-bye.